There are two examples here that are widely different. One, we have some spare things lying around. Since it's the third root, we find, hey, we have three threes. We can take one of the threes out in front. And that's nice. That's the typical thing you might expect here. But then there's this other version that we're going to do. And it is, it's shown here. I'm not sure if you can see that. But when we say the fifth root of 8, you look at that and you say, fifth root of 8. I can't do anything with that. You say, that's 2 times 2 times 2. That's 8. And I want the fifth root. And what they're saying here is that, if you multiply the fifth root of 2 more 2's, then you would have the fifth root of 2 times 2 times 2 times 2 times 2, and then you could take one of them out. And, you'd say that's equal to 2. So now that radical's gone. Because why? Well, you did something. You added, you didn't add, you multiplied something extra. And you say, why even discuss this if I have to multiply something extra? Well, if I do it to the bottom, I can do it to the top. And then the top has to live with it, and the bottom is nice, okay? And it's kind of like rationalizing a denominator. We get rid of the radical on the bottom. And that's what we're going to do here. You say the third root of 9. Oh my, the third root of 9. I don't know. What are we talking about here? That's nothing that we could come up with without a calculator, I suppose. Because, the top says this is 3 to the second power, and I was looking for triplets, not twins. And down here I have 3 to the third is 27, and I was looking for quintuplets, right, for 5. I was looking for 5, and so what can I do? Well, I'll come along here and I'll say, what I need is the fifth root of 3 to the second. Okay, and then that'll get me some more. All right, and so then I have to do it to the top as well. And you say, oh, what a mess up there. Well, we don't care about the top right now. We're just going to let the top deal with that. So let's focus on the bottom, because that's the thing that gets all the joy here. We have the fifth root of, now it's 1, 2, 3, 4, 5. Do I need to write it like that? Anyway, there's 5 threes, so one of them's going to get to come out. So I'm going to get to say, just 3 on the bottom, because you were looking for quintuplets. You found quintuplets. Okay, all right, so back to the top. What happens up here on the top? Well, let me write them as rational exponents. I have 3 to the 2 stays in with the 3, and the 3 is the root, times 3 to the 2 was inside, and now it's 5. And I'm supposed to add these. So, let's just keep going here. We say, what do? I say 3 to the 2 over 3. What do? I multiply by 5. Because I need common denominators. I have to add these guys together. Oh, what an insult. And I have 2 over 5. And I'm going to multiply by 3. Okay. So now I'm ready for my final product, I believe. Well, almost. I have 3 to the 10 over 15, right? What a terrible... That's supposed to be a rational exponent. I'm going to make my 3 bigger to make it look better. And times 3 to the 6 over 15 over 3 the whole time here. And then I'm going to say 3 to the 16 over 15. And you say, don't you have a 3 on the bottom? Yeah, I do, come to think of it. And that's to the 1, so it's 15 over 15. And I could subtract. Yes, I could. And that'd be 16 take away 15 is 3 to the 1 over 15. My goodness, so that's the 15th root. The 15th root of just 3. Well, okay, 3 to the 1, we don't write the 1. That's simple. that made it simple. I don't know if you're looking for all that. Where would we want to stop? I don't know that we'd really want to get off the train there. I think that's all good. So you go as far as you can. Do your best. Let's see. Here we go with another one. We're going to say, let's see if we can speed this up. We have 3 to the 4th power, right? 3 times 3 is 9. And then it happens again. 9 times 9 is 81. And this is to the 6th power. And this isn't going to happen the same way, is it? Because I have the 6th root of 4 on the bottom. Oh, and that's 2 squared, right? Okay. So it's not going to be the same at all. I'm going to say times, well, it's a little bit the same. 6th root. I'm looking for 4 more 2s, so there they are. I just provide them. And the 6th root, and, yeah, what can I do with that? Well, I won't worry about it for now. On the bottom, I'm going to say, I wanted 6 2s, and I found 6 2s. Do I need to write that out? You believe me, there's 6 2s, right? Alright, so on the bottom, I'm going to just have just 2. I was looking for, how would you say that? Sextuplets? Anyway, I found them, because I put some more in there. Alright, so what can I do with this? Not a whole lot. I have 3 to the 4 over 6. I guess I could reduce that. And I have 2 to the 4 over 6. But I can't put them together because these are not similar bases. Alright? But I guess I could cancel the 2. Do I really want to do that? Isn't that going to get me just back to where I started from? Well, we have 3 to the... 3 to the 2 over 3, because I'm going to reduce my fraction, times 2 to the 2 over 3. Yeah, and I'm not going to... I don't think I will do that. Is this the long way around again? We have 3 to the 2 over 3, and then we're going to end up with 2 to the 1 over 3 on the bottom. 2 over 3, take away 3 over 3 would be negative 1 over 3, so there it is on the bottom. Maybe that's good enough. We'll just stop there, huh? The third root of 3 squared, which would be 9, over the third root of 2. I'm sure you could find a more efficient and probably elegant way of doing this. But anyway, this is my answer to the situation. And I don't like the fact that we took away the... I'm going to go back over here. I don't want a radical on the bottom. I think I'm happy with that right there. I'd rather have it look like that. No radical on the bottom.